Hey guys, welcome back. Today is day 33 and we're going to talk about parallel and perpendicular lines. So let's start with the warm-up. If you missed today's class, you should try to do it. Pause the video and then go over the warm-up. So we started out by graphing the following linear equation. So I'm going to start by putting it into slope-intercept form. I'm going to do that by adding 4x to both sides, so that when I do that, I've got negative 2y equals 4x plus 12. And then I'm going to divide both sides by negative 2. So I'm going to make sure I do that to every term. So I end up with y is equal to negative 2x, minus 6. So when I go to graph that, my y-intercept is negative 6. So I'm going to start there at negative 1, 2, 3, 4, 5, 6. And my slope is negative 2. So I'm going to rise 2 and run 1 to the left. So I get my negative slope going on there. And there's my line. Okay. All right, so number 2 says, what is the equation of a line in slope-intercept form that passes through the point negative 1, 7 and has a y-intercept of negative 5? So they're giving me the y-intercept, which is negative 5, so I just need to figure out the slope. Now I have one point that's given, and I actually have a second point that's given because the y-intercept is actually a point. It's 0, negative 5. So I'm going to use those 2 points to come up with the equation for slope, which is the change in y. So 7 minus a negative 5 would be plus 5, and then negative 1 minus 0. Okay, so change in y over change in x. So we get 12 over negative 1, which is a negative 12 slope. We put the two together, and we end up with the equation of the line as y is equal to negative 12x minus 5. There's our equation. Okay, the next one, we're writing an equation in slope-intercept form that passes through the 2 points. So if we have an input of 2, we have an output of negative 7, we have an input of negative 1, and the output is 4. So there's our 2 ordered pairs. First thing I'm going to do is get the slope. So my slope is going to be 4 plus 7, because I'm subtracting that negative, divided by negative 1, minus 2. 4 plus 7 is 11, and negative 1 minus 2 is negative 3. So I got a negative 11/3 slope. Okay, I'm going to then pick a point, doesn't matter which one, and I'm going to use point slope form. Okay, so this is going to be y minus 4 is going to be equal to our slope, which is negative 11/3, times x plus 1. Okay, we distribute y minus 4 is equal to negative 11/3 x, minus 11/3. All right, I'm running out of space here, but I'm going to add 4 to both sides. Since I'm adding 4, I'll do that right down here. I'm going to add 4. I'm actually adding 12/3, because that is equivalent to 4. I want the same denominator for my fraction. So my final equation is y is equal to negative 11/3 x plus 1/3. And that's a negative in there, just so that you know. There's my equation. Okay, so homework last class. Here's the key for it. We just had a test, so there's your answer key for the homework. All right, today we're going to talk about parallel and perpendicular lines. All right, so if you recall, parallel lines are 2 lines that never cross. Okay, they go on and on forever, they never cross. Perpendicular lines are actually 2 lines that intersect at 90-degree angles. Okay, so we're going to start out with some examples. If you look at line A in this first example, and these are all lines, okay. All right, line A, looking at the line, I'm going to identify the equation. I'm going to I like to start with the y-intercept. So I'm going to look at that point right there, which is positive 6. So my B is 6. And then to find my slope, I'm actually going to find another point where it intersects with the line. So I'm going to go right here. All right, so if I look at that, I'm going to do a rise 2, run 1. So my slope is actually 2. Okay, so I can write the equation of that line A as, because all I need is the slope and the intersect, is y is equal to 2x plus 6. All right, now the second line that we have, my y-intercept is right down here at negative 4. That's my B. B is negative 4. And my slope, I'm going to use this point right here. So again, rise 2, run 1. So my slope is 2. So when I put the two together, I've got y is equal to 2x minus 4. Okay. Looking at the second example, all right, in the second example, this is a horizontal line. So again, I like to think of hoi. All right, so my equation of line A would be y equals, all right, and that's going to be y equals 3. And then my line B, okay, is going to be y is equal to, so in this case, we're going to get this, B is going to be, y is going to be equal to, let's see, -2. All right. If I look at the third example here, we're going to start with line A. In our line A, our y-intercept is -4, and our slope is going to be, we're going to cross right here, so we're going to rise 1, 2, so we're going to rise 1, 2, 3, and run 3, so our slope is actually a -1. Okay, you could have used any of the points there. And for line B, our y-intercept is going to be 3, and our slope is going to be, okay, I go down 1 over, again, a -1. Okay, so we put the two together, and our equation for line A is going to be y is equal to -x plus -4, and then the equation for line B would be y is equal to -x plus 3. All right, so what do we notice about the slopes of parallel lines? So if we look at all of the slopes, if they're parallel, they are the same. So parallel lines have the same slopes. So parallel lines have the same slope. Okay. Now let's look at perpendicular lines. Okay. Again, we're going to do the same thing. We're going to identify the equation of the line. All right, I'm looking at line A, and it starts out and it intersects right there. The y-intercept would be at 0. So for line A, we've got our y-intercept is 0, and our slope, whoops, we're going to go up 1 and then to the left 2. So this is going to be a -1/2. Okay, so if we put the two together, we get the equation of the line as y is equal to -1/2 x. All right, line B, I look first at my y-intercept. My y-intercept is going to be at +1, okay? And the equation, the slope is going to be, I rise 2 and run 1, rise 2 and run 1, so my slope is going to be +2. So the equation of this line would be y is equal to 2x plus 1. All right, so again, these are lines, so let's put little arrows on them. Okay, moving forward, all right, the second example for perpendicular, let's look at line A. My y-intercept for line A is going to be 0, and my slope in this case is going to be, I'm going to rise 1 and go to the left 3, so my slope is going to be -1/3. So I can write the equation of line A as y is equal to -1/3 x. All right, now with line B, my y-intercept is going to be, okay, that's this one right here. My y-intercept is down here at -4, so our B is -4, and our slope, there's a negative, is going to be, we're going to rise 1, 2, 3, and over, let's see, 1, 2, 3, and over 1. Yep, so our slope is going to be 3. Okay, so the equation of that line would be y is equal to 3x minus 4. Got a weird line there. Let me undo that. Hold on, there it is. Let's try it again. Okay, y is equal to 3x minus 4. All right, now the third example that we have, line A, our y-intercept is going to be at 3. Okay, so our B is 3, and our slope is going to be, we're going to rise 1, 2, 3, 4 over 1. So our slope is going to be a -4. Okay, so when we write the equation of that line, it's y is equal to -4x plus 3. All right, now the next one, our y-intercept is at -3, so let's write that as -3. And our slope, we're going to rise 1 and run 4, so our slope is going to be 1/4. So we can write the equation of that line as y is equal to 1/4 x minus 3. Okay, so if you start looking at the slopes of the two lines, you're going to notice that they are negatives or opposites. Okay, they're opposites in that if one is positive, the other is negative, but they're also reciprocals. Remember, a reciprocal, if you have, say, the number or fraction 2/3 as a slope, the reciprocal, you take the denominator and a numerator and flip them, and you would get 3/2. Okay, so in this case, the slopes of perpendicular lines are not only going to be, okay, the opposite, so -1/4 and +4/1, but they're reciprocals. So if you actually multiplied them together, they would always equal -1. The slopes of perpendicular lines always equal -1, but they are opposite or negative reciprocals. All right, and a reciprocal. All right, so with that, let's try some examples here. Well, before that, let's talk about lines. Okay, so if two non-vertical lines have the same slope, then they're considered parallel. Okay, so let's write that in. Oops, one R. Hold on a second. That looked strange. Parallel. And the symbol for parallel lines, okay, is just two lines that run parallel. That's the symbol. So an example would be if we had line A is y equals 3x plus 4, and then we had line B, pen's not working that great, is going to be y equals 3x minus 2. We could say that line A is parallel to line B, okay, because they have the same slope. All right, now if two non-vertical lines have slopes that are negative or opposite reciprocals, then they are perpendicular. All right, the symbol for perpendicular lines looks kind of like an upside down T. Okay, so an example would be if I had line A and it's y equals 2x minus 1, and then maybe I had line B and that would be y equals -1/2 x plus 4. Okay, notice the slopes would be 2. Okay, one slope, the first one, the slope is 2, and the second one, the perpendicular slope, is actually -1/2. Notice, okay, they're opposite reciprocals. So we can say that line A is perpendicular to line B. All right, so we're going to go through some examples. I'm going to go pretty fast through this for purposes of time, but please pause the video at any time and try some so that you can try to get it. Write an equation of the line that passes through -3, -5, and is parallel. Okay, so because this is parallel, all right, to y equals 3x minus 1. So right here, I'm going to identify my slope. I can easily pull that out. So my parallel slope is going to be the same. All right. And since we're writing an equation of the line, we have a point, we have a slope, we just use point slope form. So y plus 5 is equal to the slope, which is 3, times x plus 3, because we're subtracting a negative. So we put that into point slope form, and then we distribute. And after we distribute it, we subtract our 5 from both sides. Okay, we've got y is equal to 3x plus 4. Okay, so that's the equation of the line. Now to check it, you can actually put in Desmos y equals 3x plus 4, and notice, okay, put in also y equals 3x minus 1, and notice that they run parallel to each other. And then also notice that this one right here, this equation, will pass through that point. Okay, that's a good way to check it. Always use Desmos to check. All right, now we've got an equation of line that passes through this point and it's parallel. Again, highlight parallel versus perpendicular, okay? Make sure you understand what you're looking for. So in this case, I can identify my slope as -1. Well, my parallel slope is going to be the same, all right? Now I use my point right here and I put it into point slope form. Y minus 11 is equal to -1 times x plus 2. All right, I just distribute it. And then I add 11 to both sides. So y is equal to -x plus 9. All right, so those two were examples of parallel lines. Now we've got an example of perpendicular lines. This one's going to be a little bit trickier. All right, so we're writing the equation of the line. Again, always equation of line is in slope-intercept form. That's our goal, okay? It's perpendicular to y equals 2x plus 3. So I'm going to identify first my slope, which is 2. Now my perpendicular slope, I'm going to take 2, which is really 2 over 1, find the reciprocal, which is 1/2, and make it the opposite. So it's -1/2. All right, this part is super important. You're going to do point slope form with 4, -5. But what you have to do is use this new slope, okay, with point slope form, not the old one, okay, no, not the one of the original. You're finding the line that's perpendicular, so the slope you're using is -1/2. So let's set this up as y plus 5 is equal to -1/2 times x minus 4. All right, and again, now we should be pretty good at distributing it and subtracting our 5. And we get y is equal to -1/2 x minus 3. Okay, so there's our answer. Now, if we took both of these equations and graphed them in Desmos, we would see that they're perpendicular to each other and that this line actually runs through that point. Okay, so let's try another perpendicular one. This probably would be a good time to pause the video and try it on your own. All right, so first I got my slope is 4. Okay, if my slope here is 4, my perpendicular slope, because we're finding the one that's perpendicular, is going to be -1/4. I'm going to use this new slope with point slope form. So y minus 3 is equal to -1/4 times x minus 4. And I'm going to distribute it. So I get -1/4 x plus 1. Now I'm going to add 3 to both sides. My equation is y is equal to -1/4 x plus 4. All right, and there it is. Okay, so now we have number 5. It says determine which lines in each set, if any, are parallel or perpendicular. Now to do this, all I have to do is really figure out the slope of each. But in some cases, number 5, for example, let's see, for the first one, it's easy. Our slope is 5. We can just pull it out because of slope-intercept form. But for line B, we need to get it into slope-intercept form before we can pull out the slope. And we want to we'll subtract x from both sides. We've got a -x plus 2. And then we're going to divide both sides by the 5. So I'm going to do every term. So our y is equal to -1/5 x plus 2/5. So our slope here is -1/5. All right. And then for line C, we divide both sides by -10. So our y is equal to, and we can simplify 2 over -10 to be -1/5 x. So again, we pull out a slope of -1/5. So in looking at those slopes and comparing them, I can say, well, I have 2 that are the same, so I can say that line B is parallel to line C because they're the same slope. But line A is actually the opposite reciprocal, so it's perpendicular. We can say that line A is perpendicular to lines B and C. Okay. All right, so for purposes of time, I'm going to have you guys try number 6 on your own and refer back to the answer key that's posted on Schoology to make sure that you get that. All right, so now I'm going to move on to number 7. It says, what is the slope of the line that's parallel? So if I have a question like this, the first thing I do is put it into slope-intercept form. So I'm going to subtract 3x from both sides. -3y is equal to -3x plus 12. and then I'm going to divide both sides by -3. So y is equal to x minus 4. All right, since we're looking for the line that's parallel, that means they're going to have the same slope. So if this slope is equal to 1, then the parallel slope is also going to be equal to 1. So that should be my answer. Okay? All right, make sure you identify what you're looking for. You're looking for the slope. All right, now, number 8, we want the slope of a line that's perpendicular. Again, the key is putting this into slope-intercept form. So we have -10y is equal to x plus 20, and then we divide both sides by -10. So y is equal to -1/10 x minus 2. So if my slope here is -1/10, my perpendicular slope is going to be the opposite reciprocal. So instead of negative, it's going to be positive, and when we take the reciprocal of 1/10, we get 10. So there's our new slope. All right, and number 9, write the equation of a line that passes through -2, 3 and is parallel to y equals 2x plus 2. So right away I see it's parallel, so I'm going to pull out the slope. My parallel slope I know is the same, and I'm going to use the slope with the point. So I'm going to put it into point slope form. Okay, y minus 3 equals 2 times x plus 2. Okay, I'm going to distribute it. I'm going to add 3 to both sides. So y is equal to 2x plus 7. All right, number 10, write an equation of a line that passes through this point and is perpendicular. So again, all right, perpendicular. So my slope here is 1. All right, when I take 1 over 1 and get the reciprocal, I end up with 1 over 1 again. So my perpendicular slope, since it's the opposite, would be -1. All right, I'm going to use this new slope with point slope form. So y plus 3 equals -1 times x minus 3. Y plus 3 equals -x plus 3. All right, so we finish off, y is equal to -x. Okay, moving on, now we want to start to graph some. So the question says, what line is parallel to y equals 3x plus 1 and passes through the point -1, 2? So we want to graph each line, then write the final equation of each line in slope-intercept form. So the first one, we have it in slope-intercept form already. So our slope here is 3. Since we're finding it parallel, okay, the parallel slope is also 3. Now we're going to use that slope with the point and do point slope form. So y minus 2 is equal to 3 times x plus 1. All right, we distribute it, and then we add 2 to both sides. So y is equal to 3x plus 5. All right, so if we want to graph both of these, we're going to start with the first one, 3x plus 1. We start at the y-intercept. We go up 3 and over 1, or we can go down 3 and to the left 1. So there's our first line. All right, the second line is 3x plus 5. So now I'm going to start at my y-intercept of 5. 1, 2, 3, 4, 5. I'm going to go down 3 and to the left 1. There we go. So when we graph these lines, they run parallel to each other. All right. Number 12, what line is parallel to y equals 4/3 x minus 2 and passes through the point -3, -1? Okay, so again, we're already in slope-intercept form, so our slope is 4/3, and our parallel slope is also 4/3. So we're going to take that slope 4/3, because we're finding it parallel, all right, and we're going to go through this point. So y plus 1 equals 4/3 times x plus 3. We distribute. Okay, 4/3 times 3 is 12/3, so it's going to be plus 4. Our y is equal to 4/3 x plus 3. Okay, so to graph these two lines right here, I'm going to start at -2 for my y-intercept for the first one. I'm going to rise 4. 1, 2, 3, 4, and run 3. Okay, it's going to look like this. All right, the second line that we do, our y-intercept is at 3. All right, we're going to go down. I'll go down 4 and to the left 3, and go down 4 to the left 3. So it should look like this. So we have our two lines that are parallel to each other. All right, 13 now we have a line that's perpendicular. Okay, so in this case our slope is 2/3 and our parallel slope is going to be -3/2. We take the opposite reciprocal. Super important that we use this new slope with this point to get the equation of the next line. So y minus 2 is going to be equal to -3/2 times x plus 2. All right, we're going to distribute it. And we get -3/2 x plus 6/2. So remember, to multiply a fraction, I just go straight across 6/2, which is 3. So it's going to be -3 because we have a negative times a positive. And now I'm going to add 2 to both sides, sorry. Okay, so y is equal to -3/2 x minus 1. Okay, so from here, okay, we've got two equations that we're going to graph. Okay, so the first one is a 2/3 x minus, we're going to start at the y-intercept of -1, and we've got a 2/3 slope. So we're going to rise 2, run 3, okay, or go down 2 to the left 3. So there's our line. All right, and then now I'm going to take this line and I'm going to graph that. So we got a y-intercept again of -1. Okay, we're going to go down 3 and to the right 2, or we could go up 3 and to the left 2. All right, so notice when we graph them, they're perpendicular. All right, I highly recommend you try the next one on your own. Okay, I'm going to go ahead and do this. All right, you can pause the video and then check it. But this one is perpendicular, so my slope here is 2. My perpendicular slope is going to be -1/2. I'm going to use that new slope with this point and do point slope form. Y minus 2 equals -1/2 times x minus 1. I'm going to distribute it. And then I'm going to add 2 to both sides. Okay, so in this case I'm adding 2, which is actually 4/2. Okay, so my final equation is y is equal to -1/2 x. 1/2 plus 4/2 is 5/2. Okay, so when I go to graph this, I'm going to start with this equation. My y-intercept is 5. My slope is 2, so I'm going to go down 2 to the left 1. So it's going to look like this. Now the next one, my slope is -1/2 x, so we're going to start at 5/2. 5/2 is 2.5, so my y-intercept is going to be right about here. I'm going to go down 1 and then to the right 2. So notice I'm halfway between the lines. Be careful with this, or up 1 to the left 2. Okay, this is where a ruler will come in handy. Okay, so we have our parallel lines. All right, well, thank you very much for coming. Come back and review, try the homework, and see how you do. Bye.